This is a question from the 2020 exam paper. So here says the kinetic energy is increased 4 times. Recall how you calculate the de Broglie wavelength. You have the Planck constant divided by mv. And then here we are given the kinetic energy equation. E equals half mv squared. Now you can see MV here and also MV here. This is basically uh, MVV type. That's what this square means. So you might be tempted to do some lengthy calculations and lengthy substitutions. If you're a student who just started learning these things, practicing these questions, it's okay that you work it out so you can understand how these mathematical relationships work. You're going to come across this equation in physics as well. But if you are a more experienced student who has done a lot of problem solving and understood how this relationship works, when you read this part, the energy increased 4 times, then you should be able to know that your velocity doubled in this relationship. If E increased by 4 times, that results because your velocity doubled. So doubling this will lead to energy increasing by 4 times. Now, since we are talking about the same object, our object is a neutron. We are talking about the same particle. So our mass doesn't change. So that's why doubling this leads to quadrupling of E. However, let's start solving this problem, assuming that you still don't know that relationship. So this is the kinetic energy of our first situation. In the second situation, our kinetic energy is 4 times of this. And our kinetic energy expression is half mv squared, but now we know our velocities are going to be different. So for the first occasion, I would label the velocity as v1, and for the second situation where the energy is 4 times, I would label the velocity as v2. Next, what I'm going to do is divide 1 by 2. If you want, you can divide 2 by 1. Either way, you should end up with the same result. So I can cancel out e to e and my half to half, m to m, because m doesn't change. We are talking about the same particle. I will work out each step so it's going to be clear to you. I'm going to rearrange this. Now take the root of everything. So you should end up v2 equals 2v1. So what this means is that when your kinetic energy increase by 4 times, your velocity has increased by 2 times. Again, if you are a person who has truly understood how these mathematical relationships work, once you get this, you should be immediately able to plug that in here. So instead of that, you can have 2v. And you should be able to see that your lambda, the new lambda, is half of what you originally had. I'll just make it a little bit clear. So it's mv. Now you have 2 as well. So this is what your initial lambda, this is the lambda 1, and you have basically divided lambda 1 by 2. So that's a quick way to get it, but that in order to get there you have to do a lot of practicing so you know how these relationships work. If not, in order to start practicing this, we can again consider about two situations. In the first situation, this is what you have, this is lambda 1, and the second situation is lambda 2. In this first situation, I will label velocity as v1, and this is mv2, and now we can substitute this v2 by what we have found out, which is 2 of v1s. This is our second situation. Now again you can do 1 divided by 2. Divide this. You will see h to h and m to m cancelling out, and then v1 to v1. Alright, this leads to lambda 1 divided by lambda 2 equals 2. Rearrange this relationship, you will find that lambda 1 divided by 2 is the lambda 2. So your new wavelength, or the lambda 2, is half of what you originally had, which leads to the first answer choice. As I said earlier, if you truly understand how these mathematical relationships work, you don't have to do this much calculation. You don't have to spend this much time to work this out, because at the actual exam, you don't have that much time. So practice problems and learn how these relationships work. What will happen to a certain parameter if you doubles another parameter? Or if you halve a certain parameter, what will happen to the other factor? So those things, it's good to know. Those things are good to memorize, because it's going to save a heck lot of time during the actual exam.